Good afternoon, everyone. It's really a great opportunity for us to talk about our project management teaching, specifically about how we apply learning by doing in the undergraduate project management teaching, where integration of the award-winning student projects organized by Engineering Without Borders. Here is our teaching team. My name is Kegung, and I and Letitia co-lead the module together with the great support from Ian and Liliana, who are the Associate Head of School and Head of School of the Engineering and Sustainable Development, respectively. So in today's talk, I will first talk about why project management is important in engineering, the challenges in teaching project management to engineering students, and our course design to tackle the challenge, followed by the results and discussion. And we also involved external students from the previous year to share his experience of the learning outcome from this module. So first thing, why project management is important. Basically, project management concept and method are generally applicable life skills. For example, the key thing about the project are the three constraints. As you can find here, we have the quality, we have cost, and we have time that all together define the project scope. So if we think about the real life, every day, we are thinking of how to achieve something with acceptable quality, with acceptable cost, and with acceptable time. So if we fix anything in infeasible way, then that will be a problem. So for example, if I go to a mobile shop and say, I would like to have a mobile, I would like to have a brand new iPhone 12 Pro. I don't know what exactly it is, but anyway, the latest version. That defines the quality. And then I say at the cost, at the price of £300, that defines the cost. Right now, that defines the time. Then the stuff we want to keep out from the shop. Why? Because I make an infeasible condition. So to make it feasible, I have to lose one constraint. For instance, I can say I want a brand new iPhone Pro at the price of £300, and the staff can say you come back after 3 years. Or I say I definitely like to have it right now, then I may have to reduce the quality, the requirement of quality, say, okay, I may have a second-hand or a second-hand one. So this is how it related to our life. And in the engineering world, the companies, they do survive on doing the project. So we want to equip our students with skills to be prepared for their future job. A more important issue is the consequences of problematic engineering management can be very severe or even disastrous. For example, what happens if we plan the schedule of the flight in a wrong way, then the flight may crash, and even a simple delay at the airport will create a lot of mess. So that is why they are so important. But teaching project management is so challenging. So the premise issue is project management is dry. When I'm reading the textbook, I feel sleepy, so not to mention our students. And when we check the available tutorials, videos on the internet or from anywhere, and we found they're suitable for the experienced staff, particularly project manager, but not really suitable for our students. Because most of the concepts and methods are quite abstract and general. For example, the project management is defined as application of knowledge, skills, tools, and techniques to project activities to meet the project requirement. So when the students look at this, they feel this is not engineering. This is not engineering at all. So they believe those are engineering. So they really need to have something to hands-on in the lab and then to create something. So how we can convince them that for all of this work, we need project management to guide them. And we have to use project management in real engineering projects. So our solution is, since it's difficult to see the link, then we let the student do an engineering project, and by doing it, feel how important is project management. So then our course design is to apply the learning by doing strategy, which is a method for active learning. So specifically, it presents real-life problem to the learners and then guide the learners to solve the problem by providing them with hands-on activity to learn the solution. So that is project. But it's not that straightforward because we do have challenges of deciding the project. For example, if we are going to use a hypothetical project, it's very difficult to be considerate. It may be so different from the real world one. And if we provide them real opportunities, there may be capacity issue. For instance, we have the excellent Formula One project for students, but cannot be available for all the students. So I will talk about how we tackle this challenge a little bit later after I introduce our course design scheme. So for the scheme, it's majorly about linking the theory to the practice. So for the project management, we have every year about 200 students or even more. So in the lecture, which is offered to all the students, we introduce a series and methods. For example, we talk about what is scope management, and how to do the scope management, and what is schedule management and how to do it. And then during the seminar, which is much smaller groups, we let the students to apply what they have learned into doing their group project. So for example, if we talk about schedule management, then in that week's tutorial, then the student will need to develop the schedule plan for their group project. And meanwhile, to strengthen their learning, we provide opportunities such as industry learning, placement opportunities, and guest lecture from experts and also students. So we invite previous year students to share experience to the younger generation. So later on, you will see Pavel's talk with this early student we invited. So for the learning outcome, they will be able to know how to work out design solution, how to write report, and also take away a number of soft skills for the future development. So for the assignment, we also define it based on the goal. So we also have a theory part and the practice part. So the theory part will be tested by the face test. And for the practice, we use the group project. And we have the report and the presentation in the group project element. So just to give a brief idea of the group project, that how we tackle the challenge mentioned before. So we want to use a real world based project, and we want to give the opportunity to all the students. So fortunately, we have such option provided by the Engineering Without Borders, which is a charity institute. And they have this kind of engineering for people design challenge that can offer the opportunity for the student to work in a group and by looking at the real world cases. For example, last year we focused on Makers Valley in South Africa, and this year we are focused on Lobitos in Peru. So we try to understand the problem there and then think about what solution we can offer. And there are multiple design areas that covers nearly all the aspects of engineering. So it doesn't constrain the students' creativity. They can feel free to choose whatever they want to do. And we also provide opportunity by nominating some elite groups to the grand finals. And at that time, they can also talk with experts and other students to learn from each other. So for more details about this, I would like to invite my colleague Letitia to talk about it. Yeah.
Hello, thank you, Carol. Thank you very much for the introduction. Hello to everybody. I will provide some background about the Engineering for People Design Challenge that is run for Engineering Without Borders. And as Kegon mentioned earlier, it is an international organization, a non-governmental organization that believes that engineering can transform the world, transform lives, and make a positive change. And how do they do that? They have introduced the Engineering for People Design Challenge as one of their initiatives. The purpose is to embed global responsibility into engineering education and inspiring the engineers for the future. This is made through allowing opportunities for students to design creative solutions to real-world problems through sustainable and cross-cultural development projects. Each year, Engineering Without Borders, or EWB, work with local communities in the poorest areas of the world and work in the problems that they are facing. They also provide a design brief based on these problems that is the basis of this design challenge. And as Kegon mentioned earlier, this is part of the coursework for students in the second year of engineering courses. Thank you. Next slide, please. The students or the group of students can select between different areas from energy, built environment, transport, digital, water, sanitation, food, and waste. And you can see that these different design areas are also improving the quality of life of the local communities that the design solutions are provided. They can improve the access to reliable and clean energy, also to clean drinking water, and also improve the infrastructure, housing or public spaces for built environment, digital transport, etc. Thank you. Next slide, please. So by working in the different design areas, the students are able to learn more about how to address sustainable development goals. For example, in energy, it clearly the sustainable goal 7, SDG 7, related to affordable and clean energy. With the design areas of water and sanitation, we are addressing the SDG 6. Also, food is important to address SDG 2, zero hunger, but it's also important to think where does the food comes from. So SDG 14 and SDG 15 are important, life on land and life below water. Infrastructure is important for a built environment and contributes to SDG 11, which is the sustainable cities and communities, and also to the improvement of infrastructure like transport and digital contributes to the SDG 9. Last but not least, also through the management of waste in a responsible manner is contributing to SDG 12, responsible consumption and production, and all of them somehow can also contribute to SDG 13 and SDG 17 related with climate action and with partnerships for the goals. Also, if the design solutions and plan and design correctly, it can be also contribute to SDG 8 related with decent work. And sorry, these icons were not in this slide, there were too many. And related with decent work and economic growth, but also with SDG 10 to reduce inequalities. Next slide, please. So why introducing this design challenge with project management? We believe that there are strong synergies between the design process and also the tools and concepts of project management. So for example, here in the circle, we present the different design stages. And in the squares, we present the different tools of project management. So one of the things is a problem-based learning. So the students can deal with real problems that have their own constraints in different local communities. And in the design stage, it's very important that they understand the context and also make an analysis of the stakeholders to define the scope of their project. In the develop stage, they have to research which are the best solutions based on the scope that they define. So they also need resources to plan their schedules, the different tasks that the team members will have to do, and also to select the best solution. Once they have decided on the best solution, we need to have the users at the center of the design, the local communities and the people. So it's very important that the students also analyze the risk, the cost, and the quality of the design solutions. And last, also, once the design solution is proposed, it's also very important that the students evaluate the negative and positive economic, environmental, and social consequences of their design decisions that may have at the local level to these communities, but also at the global level. We also believe that this design challenge helps the students to develop or strengthen the engineering and transferable skills. And I am sure that when you hear to Pavel by his own experience, we will believe on this too. Next slide, please. Oh, sorry, I may look quite this thing. So in the next couple of sorry, in this slide, just wanted to present the different design solutions that had been participated in the grand finals since 2014. And you can see perhaps it's a little bit proud slide, but they are the design challenge is based in different communities each year. Some of them can be really rural, like in the case of Sandicola in Nepal, Bambui, Cameroon, in Lobitos, Peru, the same communities that we are working this year, or even Tamilandu in India. But it can also sometimes need to address in certain urban areas that have been poor or neglected, like Iberia in Nairobi, Kenya, and last year in Johannesburg, South Africa. And also, you can see the diversity of the design solutions proposed by the students. Some of them may look quite simplistic, some of them quite sophisticated, but there is a clear purpose on each of them, that for improving their indoor air quality in the houses, to provide early warning systems for natural disasters, to reduce waste and produce some reusable material, like in the case of the Rebuild project or the Shredder bike, or also to prevent crime in the case of the solar power street lighting. Next slide, please. And just to provide a little bit more detail about the type of design solution, this was the first team that was selected to the grand finals, and they proposed a two-latch window. We may look really simple, but there are so many benefits that in the solution that they proposed. So you can see in the picture of the house that Sandicola is located in a mountainous area in Nepal. It can be very cold in the winter and hot and humid in the summers. Also, they usually share large rooms for the most part of the family, and they are cooking inside the house, so the smoke builds up and can have some problems with respiratory diseases of the residents. It's also important to mention that electricity is not reliable, not widely available in that area. So the students proposed the two-latch door window, and that can be located in different parts of the house. So you can see in one of the diagrams of this slide that they also think about the airflow within the house. They also put the two latch doors so they can be open and closed. Open during the day so they can allow more ventilation in the house, but also more daylight so they can do more activities. And you may not be able to see a mesh, but this the design solution also have a mesh that is like a mosquito net, because the mosquitoes can be quite not available, but abundant during the summertime. And also they incorporate a curtain, a woolen curtain. So in the winter, they can use that curtain and close the windows so they can remain warm. So you can see that a simple design like this have a lot of benefits, such as a better indoor air quality, a weatherproofing home, also provision of more natural daylight, insect management and disease prevention, even you think about it. And because they also think about the different materials that they were using, they investigate the species available in Nepal. There is also opportunities of job creation. And just want to finalize that I think that the students themselves find very rewarding that they can make a difference to the communities. I will pass again back the microphone to Kegon. Sorry. Thank you. Kegon, you are mute. Sorry.
Yeah, sorry, I was muted. Hope the introduction before gave you a clear picture of the conceptual design of the course. But it's not that straightforward when we try to implement it, because despite we provide the student project, but for them, they may still understand it like theories are the theories, and project management and real world engineering project are the engineering project. So how to make the link very clear and how to make sure they can apply this into their work. So we need to provide hand-by-hand guidance. So here I mentioned two examples for information. For instance, for the scope management, we let students know about how to define the scope of the project with a clear aim and objective. So they also need to know how to work this out. So the strategy we use is theory, daily life example, and practice, and show clearly the links between them. For example, for defining the project aim, we introduce a definition. So that is one of two sentences that specify what the project is trying to achieve, not what to do. Then we provide clues for the student to think about their aim. So we provide a way of thinking. And the same for the objective. So we clarify this like the objectives are the milestones that the student need to complete step by step to achieve their aim for the project. So other than that, we also provide examples. So for instance, we have the bad examples and we have the good examples, so that we use a good one to further clarify how to define the SMART aim, particularly with the success criteria being very clear. And this also linked to their study. For instance, we mentioned that for their coursework, of course, they always want to know how the work will be evaluated, what is the success criteria. And we also provide a template to them to again try to provide them as many clues as possible of what information they need to collect and how to derive their contents. For example, by using the template, and they can understand what specific problem they need to look at, for instance, for the water scarcity, and what are the causes to the problem. And based on that, to understand the factors that poses the issue, and then select one of the key factors and to think about to what extent they can solve the problem. So this kind of root cause analysis helps the students really to understand how to develop their aim and objective step by step. And another example is the cost management. Based on our observation on previous year students, most of them do not really understand for the life cycle cost, we need to consider both capital and operation cost. So in that, because they always think that the cost only involves, the money needed for buying the materials, to hiring the labor, and then don't think about the maintenance of the solution. So to solve this issue, we provide the daily life example. For example, how does a company cost only £1? And how comes the German prince would like to sell his castle for only $1? So with this clarified, then they want to know how to calculate the cost in a more comprehensive way, and then we will provide them the solutions. So again, we try to link the theory, the real life examples, and methodologies all together. So personally, I believe that the education is to trying to provide the students a way of thinking, to use their knowledge to understand the world, so that they can know how to, use what they have learned from the world to guide their studying, and also use their knowledge to change the world. So it's just like as a knowledge, to give them a third eye to create additional version that they can translate everything they see in the real life into their system of knowledge. So this is our purpose. It's challenging, yet very straightforward. So the more difficult part is something beyond that, which is what I'm going to talk about next, about the problem-solving skills and how we let the student know the standard of good work. It's not uncommon that for any problem, for instance, for the water scarcity problem, we say the village doesn't have very good water infrastructure, and the student directly say, let's build a new infrastructure for them. If the road condition there is not very well, and then they say, okay, then let's build a new road for them. So if the solution is that simple, then that won't become a problem. So we have to expand this in detail by using their daily life example. For instance, whenever we have a blue screen of our computer, our first solution is never ever to completely reinstall the system on the computer or to buy a new computer. So we always try to think about the easiest, simple, and profound solution. So in this regard, we use examples like this to expose them to a problem, and then to guide them to know how to think about it. For example, in Kenya, availability of shoes is low due to lack of resources. What is their solution? And we show them the steps of analyzing it. So for instance, first we need to do the Python analysis, which consider the political for the P, and the economic for the E, as for the social for the S, and the technology legal environment, to ensure that for any problem, we try to consider all the factors without missing any important one. And based on that, we provide a clue, like what kind of shoes people there are looking for and why. And some students are able to figure out people then need scandal because of the hot weather there. And why it is a problem for local people, what are the common ways to get shoes, and why is it currently not working there. We try to help them to define the problem and the design criteria. For instance, what is the key causes of the problem, and what are the specific criteria needed for the shoes. So let's say the acceptable price, the material, which is the design requirement. And then we guide them to explore all available solutions, particularly based on literature review rather than brainstorming, because many of them, they are creative, but they directly, try to just think about things from their own mind without looking around. So it's just like reinventing the wheel. So we avoid that. And again, we give some other tips, particularly about the need to adapt the solution into the local conditions. For example, for simple scaffolding, automatically our student may think about to use this one, a metal one. But actually, for the local people, they don't may necessarily need a high standard one, and they are rich in the forest resources, so they may want to use this. So we have to give this guidance on them. And then we tell them how to justify the solution. For instance, the typical tip is, if they need many words to justify their solution, it's very likely the solution is not a convincing one. And at the last stage, we review the real world solution for that problem and to actually give them a very strong impression. So here is the example. So actually, the people there are using the deposed tire from the vehicles to recreate, some scandals. And actually, it's a great job for the local shoemaker, and it's very easy to make, and it has a very low cost, only $1 or $5 each. And actually, that is so-called of self-explanatory, simple, and profound solution. And about knowing the standard of good work. So once they have the solution, we want to enable them to evaluate by themselves. So here we have a typical example. So that is a poster designed by an excellent team qualified for the grand final 2 years ago. And they designed this kind of portable solar powered street lighting. And they sent us the poster design just 2 days or 3 days before the deadline. And when I looked at this, I feel, no, we can't let it go like this. But there's no enough time to really teach them step by step. So if they submit this, then they may not have a very pleasant experience there because they may not receiving very good comments. And it may also doesn't make a very good, representation of our DMAU's work. So what we do is we'll provide them a lecture sample design. It's a little bit tricky, but we have to do. And based on that, the students redevelop their poster, and you can see, personally, I feel they significantly improve their work, and actually they get some very good feedback from the final. That is actually how we implement the module. In terms of the results, we get quite good comments and mark from the students. So we have a score of 3.8 out of 5. So our student also gave us first class mark. So we really appreciate that, which is average of 23 evaluations. Actually, we don't have any score lower than 3. So the range is like this. And more encouragingly, we have Pavel that be able to secure the top prize out of UK university and the runner-up prize over 1,025 university teams. So it is a very great achievement. And Pavel will talk about his experience and also the learning outcome from the module soon. So to quickly conclude, actually we found that the framework used can engage learners and make sure they are able to deliver high quality work because they are highly motivated by this kind of national competition activity. And it also raises awareness of the UN SDG goals, as Leticia said, and also let them know the responsibility for the engineer to the society. Yeah. So that is my part, and now I'm translate to Pavel. Thank you very much for your attention.
Good afternoon. I'm Pavel. Some of you may know me because I'm a third-year mechatronics student. I was a team leader of the group which secured the runner-up prize in last year's Engineering Without Borders Design Challenge, and today I was invited to share my experience of how I found project management useful for both the water gathering system project and our studies. Specifically, I will introduce the following learnings in the order of implementing our project: understanding the key factors of making a good team and team roles, problem formulation and problem solving, the importance of planning and how to do good planning, linking different engineering subjects and skills together, and the importance of project management in the real engineering environment. Before talking about each point in detail, I would like to briefly introduce the background of the project we decided to do. The area of our project had to focus on was Johannesburg, a city located in South Africa. There were 8 design areas we could choose from. As you can see, we decided to focus on water, and it was also the first moment when we used the knowledge acquired during the project management lectures. Based on personal analysis and Maslow's hierarchy of needs, water access seemed to be the most reasonable and the most life-changing choice. Africa is affected by the water crisis, which is lasting for years. People in Johannesburg often do not have access to drinking water. Frequent power outages make the situation even worse because underground pumps stop working, what cuts people from two important, I would even say basic resources. The infrastructure itself is also not in a good condition. The result is that the price of water is very high. Interestingly, frequent rains cause many floods, which combined with garbage laying almost everywhere cause additional pollution to the local reservoirs. We decided to use this weather phenomenon for our advantage and create WGS. The name of our system describes its purpose. It is supposed to reduce the impact of the water crisis by gathering and filtering rainfall water, which could be used later for any basic needs such as washing, cooking, cleaning, and even reused in form of grey water to flush the toilets. The first lesson I've learned was about teammates' choice. In the case of this module, we had an opportunity to form the teams on our own, in contrast to the first year group projects, where we were forced to team up with some people who never attended a single lecture or workshop. Now, after the challenge, I can see that I've made a lot of mistakes in this field, as the other people in my team had different goals than me. But that's an important experience, and I feel really good with what happened. Another lesson was about being a team leader. This challenge has shown me how important and responsible this role is. I mean, I worked as a team leader before, but there is no comparison between engineering project and one of my previous jobs. I've learned a lot about understanding the others, people's motivation, their approach, obstacles which can interfere with the implementation of our plans, and time and resource management, mostly on my own mistakes, but it is some way of gaining experience. Lack of firm actions from my side was one part of the problem. Early in the project, 2 of 5 members couldn't help at all due to their personal reasons, and they had to redirect their tasks. The second part of the problem was exaggeration of the situation of the remaining teammates. I thought they were busier than me, so I kept taking larger and larger portion of the project on me so as not to overwhelm them. At the end, I did approximately 70% of work on this project, which translates to anywhere between 220 and 270 hours. I have also learned that as a team leader, I have to leave my personal issues on the side, especially when the project is in its late stages of development and no one can replace me and take care of it. I'm talking about this because I had to reconcile full-time job with the project development, and at the same time my father passed away, so I had a lot of administrative things to deal with, and the pandemic didn't help with it at all. This is how, in my case, the team leader's responsibilities met reality. It let me experience how difficult and demanding this role is, and I appreciate this lesson. After forming a team, we started to analyze the document provided by the EWB. It was also the first moment when we had to start managing our time and set some deadlines for this part of the project. We came up with a couple ideas, each of us prepared at least two, and after that, we have done some research during which we were trying to implement some early personal analysis, and it was another important experience. We couldn't make a detailed research about each idea due to the time limitations, so after consideration of pros, cons, and previously mentioned factors, we had to decide which project has the greatest potential and chance to be successful. Our decision was also supported by the scope triangle, which we have used more or less subconsciously in the entire project, applying it to various elements. One more important factor was also our knowledge. We didn't cross out any sector ideas straight away. However, we were aware that some areas are beyond our skills and we shouldn't choose them as there would be more work than we can handle. To give an example, we had to choose a water filter for our system, but even after researching it, I am still not certainly sure if the water will be safe to drink and comply with the local regulations, as my knowledge in chemistry and biology is not as great as I would like it to be. The next step was planning, where we finally could create work breakdown structure. Gantt chart, and network diagram, 3 things about which we have been taught during the project management module. Thanks to them, we were able to break our idea into pieces and plan everything in detail, setting some milestones and deadlines which were critical at that point because it wasn't simple 2 or 3 weeks research, but entire several month plan covering every aspect of WGS. These tools also helped me to see what we still need to cover, which section is delayed or incomplete, and delegate the task easier when we met an obstacle. In addition, we have used quality and risk management to assess hazards associated with various situations, what improved the health and safety measures, and highlighted some situations which could be avoided by applying simple changes to our system. I have also noticed that there is no guidance what exactly should be included in them, as it all depends on what we are designing, how big our project is, and how well we can think outside the box. I will give an example the same as in the previous section. Our team considered aspects from management and design through manufacturing and distribution till installation and even marketing, what I believe was standing out from the other projects. I must say that I appreciate these tools and understand their role in real engineering environment. They are useful for me even now during my 3rd year because I can plan my individual projects much better. The design stage of the project allows us to link knowledge and skills obtained from other engineering subjects together, in example, to get experiences of applying them into engineering solutions. That was the moment where we could use not only the knowledge and experience related to project management, but also the CAD skills gained in the 1st year, or for some other students, also in the 2nd year. Combining them allowed us to model and see our system, but due to the time constraints and lack of skills, some of them are not as precise as we wanted them to be. It has also shown us some of the problems which we didn't take into consideration. For example, we've forgotten to add gutter connectors, brackets, and downpipe in our initial design, and we found it out during the assembly of our system. We have also learned new features of Creo, the modeling software, which weren't shown to us during the 1st year. None of the other students knew how to create an animation using this software, so I decided to combine my interest in video editing with the project. I have finally created an advertisement concept and simple animation which presents our system. The previously mentioned problems allowed us to think about our target group a little bit more, and after consideration of different additional solutions, we decided to make our system modular, what again refers to scope triangle, as everyone can find a suitable variant for themselves, depending on their requirements. After the results were announced, I received the feedback from the EWB, thanks to which I could see what had been done wrong, what elements we could have added, what additional solutions could have been implemented, and how our system can be developed in the future. There was one more lesson. The best idea is to assign people to tasks which are related to their course, if possible. In this way, they won't feel that they have to research something unrelated to their challenges they can meet in the future, and it can also help to speed up the research and design because the students already have some basic knowledge about the subject. However, we should be open to learning new things which are beyond our discipline and do our best when we research a specific topic. Eventually, I understood the importance of project management in the real engineering environment. It makes the planning of big and complex projects much simpler when the available tools are used properly and qualitatively. Using them, the engineers can visualize not only the system but also some abstract elements which otherwise could be omitted, exposing the company to additional costs. Project management also allows us to set milestones and show dependencies between specific tasks or teams if they are located in different countries, supporting communication when there is a big time difference between them. Finally, it significantly affects the time and human resources management, as we can see what deadlines are set, which tasks are critical and should be our priority, what would be the approximate duration of the project, and where the processing capacity should be redirected in case of any delays or if certain task was completed earlier than assumed. These elements are critical for a successful company, and that's why we are taught about project management. At the end, I would like to summarize the outcomes of the project. My motivation was to create something useful for people that will raise living standards in Johannesburg and solve at least part of the problems, and I believe that I've done my best. I have experienced how difficult and challenging the real engineering projects are. There were obstacles which we couldn't overcome due to the lack of knowledge or skills. I have made mistakes in planning, work division, and understanding the team roles. We as a team also had different motivations and ambitions regarding the challenge. Despite this, however, we were still able to secure runner-up prize, learn about the use of the project management, and apply it to real engineering problems. We have also developed our skills and knowledge in various sectors. This challenge is valuable to me, as even if I made mistakes, I can still reflect on them and try not to repeat them in the future. I have also gained much more practical experience than I would without it, and improved soft skills which are appreciated by employers. Finally, I can see a potential of using some elements of the project management in my assignments and everyday life. I think that this mindset was one of the important factors of our success, and I hope my presentation and this achievement will be some kind of inspiration for the other students. Thank you.
Thank you all. This is all about our presentation. Thank you very much for your attention.